4 liters at STP. In fact, 1 mole of any gas will take up the same volume at any temperature. So what I'm saying is it doesn't matter what the gas is, it'll always take up the same number of liters. So what we're saying is that there's a relationship between moles and the volume they take up. That means there's also a relationship between moles and the pressure that they take up. If you only have a few moles, you'll only have a little bit of pressure. If you've got a lot of moles, then you're going to have a lot of pressure, and that's what we're seeing here for the X's, for example. I'm trying to say that we've got a lot of X's here, so that would be a fair amount of pressure, and we've only got a little bit of water here, so that would only be a small amount of pressure for the water. But the point is that if we were to put a pressure gauge on this particular system where we've got the X and it's above a sample of water, and that means that we've got a little bit of water vapor as well as water liquid floating around in the container, that the P total will be the combination of the pressure of X plus the pressure of the water. So P total equals Px plus pH2O. Now the vapor pressure of the water, or the pressure of pH2O, or the vapor pressure of the water, is going to be completely dependent on the temperature. And it doesn't matter how much water is sitting in the bottom here, we're always going to get the same kind of vapor pressure of water, and it's all going to depend on the temperature. And what you'll notice is that as the temperature increases, that the vapor pressure of the water increases, and that's not really a surprise. So you'd expect to see more water vapor in this container as the temperature goes up, as more vapor gets heated and escapes the liquid form of the water. So as you can see here, we get to 45 degrees and the vapor pressure, if this is in millimeters of mercury, becomes quite appreciable, 71.9 millimeters of mercury. And we keep on going up here until we get to 100, and when the vapor pressure becomes 760 millimeters of mercury. This is not a coincidence. 760 millimeters mercury is atmospheric pressure. And this is actually the definition of normal boiling point. When the vapor pressure reaches atmospheric pressure, that is the temperature at which the liquid is boiling. So that's what's happening with water at that point. Generally speaking, we'll be talking about water probably more in the range of 20 to 30 degrees. So we're talking about pressures in the range of 17.5 up to 31.8 millimeters of mercury. This comes in to be most useful when we're trying to find the pressure of a gas when it is collected above a sample of water. So when a sample of gas is collected above water, we can find out what the pressure of the water is as long as we know what the temperature is, and then we can also have the total pressure. So the pressure of gas would be gotten by taking the total pressure, which is what would be read on the gauge, minus the pressure of water at the temperature that was given.